Good day. Our topic for today is all about work and power. So let's start with this question. What is work? In layman's term, maybe we'll be thinking that work is an activity involving mental or physical effort. Or some of us, it means earning income. But in physics, we will have this definite definition. Work is done whenever a force moves something. So what do I mean by that? Okay. To know more, let's have these slides here. So we have conditions for work to be done. First, there must be a force acting on the object. So I want you to look at this man. He is pushing this box. Okay. So let's check. Is there a force acting on the object? Hmm. So I think the main question here is this man has done a work in this box? Again, is this man has done a work in this box? So there must be a force acting on the object. So check. Second, the object has to move a certain distance called displacement. So notice that this man is pushing this box, and you will ask if once this man applied the force in this box, is this box moving? Yes, it's moving. So, condition number two has been met. And last, there must be a component of the force in the direction of the motion. Means the object must move in the same direction as the force. So, again, the main question is the man has done work in this box? Condition number one, is the man pushing this box with a certain force? Yes. Condition number two, is this box moving to a certain distance? Yes. And three, is the component of the force and the direction of the movement of the box is the same? Yes. So therefore, in this kind of situation, the man has done work in this box. So in short, work is done when a force causes an object to move in the direction that the force is applied. Mathematically, it is expressed by these formulas. If the force and the displacement are parallel, okay, to each other, you can use this formula here. If they are not parallel to each other, only the component of the force parallel to the displacement does the work, then we can use this formula, where the angle is the angle between the force and the displacement. So for example, so if this is the force and this is the displacement, so you have a certain angle here at the middle between them. Or let's say for example, this is the force and this is the direction of the displacement, then you have a certain angle here. Later on you will delve into this more. And then we can use this one. For example, if you're gonna break down the force, because we all know in our previous discussion that force is equals to mass times acceleration. So if you're gonna break this down, then change it to mass and acceleration, then becomes like this. Okay, and these are the physical quantities together with the symbols and units related to work. So we have here work, the symbol is W, and the units can be joules or Newton meter. We have the force, the symbol is F, and then the Newton. For displacement, the letter D or meter. For mass, M, and the unit is kilogram. Acceleration, the symbol is A, and the unit is meter per second squared. There is also a formula for vertical work. We have here work is equals to mass times gravitational acceleration times distance or displacement. You can have also this one. Work is equals to mass times gravitational acceleration times height. So what is joules? Okay. Joules is defined as the amount of work done on a body by 1 Newton force that moves the body over a distance of 1 meter. It is named after James Prescott Joule. Okay. At this point, you will have a very short activity. Okay. You have to tell me if the given situation is doing work or not. Okay, here. Let's go to sample number one. Is this woman has done a certain work in these two bags? Okay. First condition is this woman exerting a force in these two bags? Yes. Okay. And in what direction? Okay, that would be upward. Upward. Condition number two, are these two bags, okay, move to a certain point? Yes. Okay. It has a displacement going in this direction. Okay. And condition number three, are there components or is there component of force being exerted to this object, so these objects? The same with the direction of its movement. So look, so the force is going up, but the displacement is going in this direction. So condition number three has not met. Okay, so no. Okay, there's no work done by the woman to these two bags. Here, okay, as this um, woman, I think, okay, exerting a force. Yes, it's going up. Okay, and what's the direction of her movement? Yes, it's also going up. So therefore, in this situation, there's work. How about this one? And this man is pushing this column here. Is there a force being exerted by this man to this wall? Yes. Okay. There is a certain force. But how about, is this column moving? No. This column is not moving. The displacement is, oopsie, is zero. Okay. So is zero. So therefore, even though you exerted a lot of force, but there's no movement, then it's not okay. So this man hasn't done any work into this column. How about this SpongeBob? Okay. The question is SpongeBob has done work to these two cute, what's this, bunny or teddy bear? Okay. So is SpongeBob exerting a force? Yes. Okay, then it's going up. Okay, how about with these two objects? Are they moving? Yes. Okay, from the ground up to this point here. Okay. So in short, um, SpongeBob has done certain work with these two cute stuffed toys.